All right, so in this problem, it says an electric drill starts from rest. So starting from rest means that, whatever, if we're in angular units, my original omega will be 0. And rotates with a constant angular acceleration. Now, constant angular acceleration doesn't mean 0. If it's a constant angular velocity, the acceleration will be 0. It just means it's a number that's not going to change, and it means that we can use kinematic equations in order to solve it. After the drill is rotated through a certain angle, the magnitude of the centripetal acceleration of a point on the drill, it doesn't matter where you are on the drill, just like the last one, it didn't matter where you were from the axis of rotation. There's going to be a place where in this problem, there's a point on the drill where the centripetal acceleration is twice the magnitude of the tangential. So my starting point is this. My centripetal acceleration is twice the magnitude of the tangential acceleration. So that's the key thing. Centripetal acceleration is twice the tangential. And that's going to get us that one fact that's the tricky fact. We actually have some, there's one other thing that's going to be a little tricky on this one, because in the last problem, they gave me what the alpha was, right? And I was able to then solve for omega. This one, they're not giving me an alpha. So I'm going to have to carry the variable in the problem for a little while. So AC, again, just like the last problem, AC is going to be r omega squared, and that will represent the final angular velocity, because it's we want to know at some later point it's starting from rest. So I know it's not the original, so it's the final. And that's going to equal 2r alpha. Just like the last problem, the r's cancel out. Now, I can either write omega f in terms of alpha, or write alpha in terms of omega f. I'm going to do it this way. I'm going to say that if omega f squared equals alpha, then who can tell me what will omega f equal? If omega f squared equals 2 alpha, then what will omega f equal? Square root of 2 alpha. So I'm just going to leave it like that. I'm just going to leave that as my variable. And then what's my omega O? What is it? 0. Now my alpha is just alpha, because I don't know, again, I don't know what that variable is. So I'm just putting my variables, and since if I'm going to write that, it's square root of 2 alpha, then I'm just going to write that as alpha, because I don't know what the value is, but we'll just call it alpha. And now, just like the last problem, if they wanted, they could have asked, how long does it take for this to happen? Which would have been time. But in this problem, they want us to figure out what angle did it move through for this to happen. So what's my unknown? Theta. So theta is the unknown, which will be in radians. And so we get that. Those are my facts. So now, with that, the only fact we didn't write down was time. So we're going to have omega final squared equals omega original squared plus 2 alpha theta. And can I cancel anything out? What? Right, I cancel out the original omega. So now I'm solving for theta. So what will theta equal? Theta will equal what? Good. Omega final squared over 2 alpha. And what's nice about this is, look, we want omega final squared, and we have omega final, and it's the square root. So if omega final equals the square root of 2 alpha, then what does omega final squared equal? 2 alpha. So I get 2 alpha over 2 alpha. And I know my answer has to be in radians. So what does that equal? 1. Everything cancels out, and I get 1, and my units are radians. Again, if you do this, you'd say, I don't have any units. Because if I have 2 alpha over 2 alpha, then everything cancels out, and I have 1 without any units. But again, the radian unit is this crazy unit that doesn't really, it messes things up. And so it does give us radians for the unit. But, it doesn't give it to us, but we know it has to be in radians.